begin.
You don't have any things like that. Right. I'm there Tuesday, Thursday, Monday, Wednesday. Wednesday. Right. When you're showing one comes out as class, mine has class.
So I got homework last time. From I know how far. I give it to both classes, right? The homework. How was it?
Was I there that class, sir?
Huh?
Was I there that class?
Everybody would have been either remotely or physically. Alright? So it was so find the center. No, it was an exercise question. It says first express
Oh, okay. No. Yeah.
Yeah, I don't know technical difficulty here just now.
Sir.
I had a freeze in the screen. Huh?
Start this.
Alright. Never mind, you got before night as well. Yeah? So I'll try my best to keep an eye on it. Alright, so express 2x squared plus 2y squared plus 3x plus 4y.
No, minus.
4, where are you?
Yeah, man. Minus 3x
Oh, minus 3x
plus 4y minus 12.
Okay. Uniform. Alright, so let's do it in turns. Alright? So what form is this? You see, it's really about recognizing the form, eh? And that's a completed square form. So that's basically telling the exam, telling it to complete the square. You know, come to think about it. That question not even valid. This that question not valid, people. Right? I don't know why I put it like that. You see why you're not supposed to copy it? Copy that question. Right? So it can't be put in that form. The form that can be put in is it can be put in that form. Right? So let's just see what's happening. Everybody follow that? As in, you're supposed to recognize that it is a circle, somewhat, right? But you must also recognize that it's a quadratic in x and y, and a quadratic in x and y can be these two forms. You know? So the solution here, although it's a crappy question, Mr. K might have some crappy questions too, but you have to just try and interpret to say what do they really want or what do they intend to write. Or sometimes the intention you have to think about, right? So I apologize for that question. So if you have stuck on the question, it's my fault. All right. So 2x squared minus 3x, leave a space, plus 2y squared, yeah, plus 4y, leave a space, minus 12. Be careful though. This is an expression, right? So you have to be careful of how do I balance an expression? Note that I don't have two sides of an equation anymore. Right? So instead of adding the same thing to both sides of the equation, I may be required to add and subtract from the same side of the equation to balance the equation. That making sense? If I add an equation, A equal to B, I can add something to both sides. And it will remain the same. Is that so? Yeah. But if I add an expression, A plus B, so as to not change the expression, if I add C, I need to subtract the C. So it's about working on two sides of the equation as opposed to working with only one side, effectively an expression. Fair enough? Okay, so it's clearly in there, but yes, so let's go. Not sure what to do. It's the intent. So let's go. Yeah. So I guess I'll ask it to take a look at it afterwards. After this homework, I will try and solve it. Right? Sure. So here you would have. I would want to bracket that, and I would want to bracket that, right? Okay. The question is, can I complete the square of this quadratic? Possibly. Yeah. Possibly. That's a yes or no.
Yeah, it's neither. It's possibly.
So, for real, can I complete the square? Why not?
Because coefficient of x squared is 1.
Coefficient is not 1. So what do I do with that coefficient? I need to factor it out.
Yeah.
So, not 1. So I would have to take out this 2. When I take out that 2 out of that, I'm left with x squared minus, be careful, 3 upon 2 x. And the space is still there, right? Plus 2. I need to take out the 2 again.
Y squared plus
2y. In space.
minus 2.
Doesn't remember, I never take out anything of that, right? Just be careful now, you know. Now, if this is the case, what needs to happen now? I now need to say half coefficient of x all squared, eh? Yes? So in that case, and so on easy with this computer, I might change it out. Plus what is half of this fraction? How do I find half of a fraction, guys?
Divided by 2.
Divided by 2. In essence, what am I doing? What is it then? Since you're dividing it by 2. Negative 3/4. So to find the half, just multiply the denominator by 2. That's all I think of it. Plus, what's a half? So that's a plus 2 divided by 2 all squared, right? But I have changed the expression. Now I need to add back this. I mean, subtract this since I added and subtract that. But there's two big different problems here. What did I add? I know that I'm subtracting 2 things, right? But what did I really add here? Did I add just minus 3/4 squared? I'm going to say no, because if I expanded this bracket, you realize that I added 2 times this. That making sense? So anything you factor out, you have to remember that technically that's what you would have added, right? So in that case, I am really subtracting -2 times minus 3/4 squared, and I'm really subtracting 2 times, because this is not what I added. I added 2 times that, right? It's just another thing for you to look out for. And now the expression will have remained the same, right? If it is that you have followed that procedure, then you would have had x here, minus 3/4 here, square, yes? Whatever is in brackets put down here, plus twice and this would have been y plus 1 squared. And pick up my calculator and work out all of that over there. Guys, that was exactly what the far right. Now where's the original? One of the it's from last Saturday. No, this as in that's something. Wait, from Sunday's class. Where's the Sunday? This is dark. Well, I don't know. So we're like in on Sunday.
You were here some access. Same.
Oh, it's just that you're saying, oh,
I mean the tape.
What's that? Somebody confirm minus 121 upon 8. Is that correct? Where's the calculator? There it is. Yeah.
Yes, sir. Yes, sir.
Yeah.
Go this way, sir.
I don't think. All right. And then we are now supposed to do what? Enter otherwise what? Enter otherwise. No. Enter otherwise. Determine. Is center. It look different, eh? Center and radius of the circle. 2x squared plus 2y squared minus 3x plus 4 minus 0. So you realize what happened here? If it is that we have done this correctly, Justin, follow again, since you're not entirely sure that you're in the right class, right?
So that's the thing. It just looks really weird.
I know it looks weird. First, they said, given this expression, it was not an equation, right? And they can do that in, they can do this in the exam. They can say, put it in this form. What we need to recognize is the form. And we need to be confident that this is a circle. And when I look at this, the first thing that's supposed to come to mind is that really and truly this looks like some form of a circle. The center radius form, some form of it, because it's not supposed to have an A in front of it. If it was real center radius form. Is that true? Yes? So, irrespective of that, I need to recognize that what they're effectively asking me here and here is to complete the square of my x, my quadratic in x, and my quadratic in y. So I will set out just to do that. How do I complete the square? You see, before I usually use two sides because with an equation I was allowed to do that. Where I add to both sides to balance the equation. But this is an expression, it has no two sides, it only have one side, the expression side, right? So the first thing I did was to put x and x together, the y and the y together, but I know that's a quadratic and it needs to have a last term, typically, right? So we'll leave a space, and then we'll keep the 12 further down, but it's still on the same side of the equation, you know? Then I said, hey, how do I really complete the square of these two brackets? I complete the square. Well, in order to complete the square, you would realize that I need to have what? The coefficient of x squared to be 1. But be careful. If I factor the 2 out of this x squared, I need to factor it out of all of that bracket. Otherwise, I'll be telling a lie. You know? Because when I expand it back, it was supposed to give back this. Say 2 times x squared is 2x squared. 2 times minus 3 upon 2 is minus 3x. Fair enough? Same thing here. I would have first factored out that 2, but I need to factor out that everything that is inside that bracket as well. Fair enough? Having done that, you have seen a quadratic whose x squared term or squared term has a coefficient of +1, lower, and whose y squared term has a coefficient of +1. Therefore, I can complete the square based on our rule. So, and the rule said, if I have a quadratic wherein my x squared term has a coefficient of +1, then the last term must be half of the coefficient of whatever multiply x, and half of this fraction is minus 3 upon 4 all squared, and I need to add it here as well. Half of whatever multiply y is +2 upon 2 all squared. Now I'm saying I need to balance the equation at the same time. I put in this just so that I could have built completed squares. But I need to balance the equation so as to not change the value of the expression. If I added something here, I need to subtract it outside. Right? But I was saying to you, unlike in the first example that we did in the respective classes on Friday and on Sunday, we would have just subtracted this. In other words, we have just added this to both sides, right? But now because it's one side, we have to subtract it and add it so that it's to cancel it out effectively, right? But what did we add? We did not add one of this, we added 2 of this. So if you expanded it, you will realize that this is 2 of this, right? Likewise, we added 2 of this. Therefore, we need to subtract 2 of those, right? And then we'll pick up a calculator and I evaluate it out. You know? And then that is done. If they had asked you clearly, what is A? You would have said A is equal to 2. That makes sense? H is equal to minus 3/4. Everybody seen that? Yes. K is equal to 1. And J is equal to minus 121 upon 8. If they had said clearly identifying I, J, and K, but clearly nobody's seen down here on the video anyway, right? But if they had asked to identify them, clearly we would be required to just say what they are. You know? No, this says hence or otherwise find the center and radius of this. I could have done otherwise, right? By saying right here. So let's do it in two ways. Method 1, which is from the hence. What do you realize here? This is exactly what I've just transformed. So hence me right back what exactly You just no, all of that is just set to 0. Can you see that? Yes? Because this is equal to that. Then, remember, it's not a circle or not in center radius form unless there is nothing multiplying that bracket, no? So I need to divide. First of all, I need to say, all right, 2 into x minus 3 upon 4x squared plus 2 into y plus 1 squared is equal to positive 121, right? Then I need to say x minus 3/4 squared plus y plus 1 squared is equal to 121 upon 16. Yes? No, I'm all good. Because now I can find the center. The center would have been 3/4 minus 1. And the radius, in this case, would have been the square root of 121 upon 16. And you know how I know that this is a nice, this is correct? Because anytime you get numbers that are perfect squares under square root, you know that Mr. K built that question just for you, right? So this is going to be the root of 121 upon the root of 16, so that is 11 upon 4 units. Can see that up, and I'm going to try and figure out what other topic to be. You could